As we've seen, we can divide two polynomials using long division, and long division always works no matter what. But sometimes it's a little bit easier to use this other method when a special type of polynomial is being divided, and that's called synthetic division. And so all we're doing is we're looking to be able to divide synthetically when the divisor is of the form x plus c. So for example, if you had x plus 1 or x minus 3 or something like that, those would be okay to use with synthetic division. However, if you had something like 3x plus 2, that wouldn't work, or even something like 9x minus 1. In other words, if you have any number other than 1 as the coefficient of your linear x minus c, then unfortunately you couldn't use synthetic division. All right, so if not, then you just use your long division, right? So all we're going to do is we're just like the first type of the long division, we're going to arrange the polynomial in descending order, and we're going to fill in a 0 as the coefficient for any missing term. Then what we're going to do is we're going to write the c for x minus c, all right? And essentially, if it's positive, then you make c negative, and if c is negative, it just stays positive, right? And we're going to write the coefficients of the dividend. So we're not going to write the actual x squared or x or anything like that. We're just going to write the coefficients. And then we're going to write the leading coefficient in the bottom row. And then we're just going to multiply c times whatever value is just written. We're going to write in the next row. We're going to add those values. Okay, so it's probably better for me just to go through and do a few problems with synthetic division because it's not really that difficult once you see it. And then I can show you how to write the solutions to this. Okay, so this is a problem that we already know the answer to. Remember in the first video, we took a look and we got the answer to this was x minus 7. So here's how we're going to set this up. We're going to always draw a bar like this. This number, you take the opposite and you write it on the outside. All the coefficients are going to go on the inside. So notice there's a 1 here. So we just write a 1. And then we have a 10. And then we have 21. Now, what I'm going to do is I'm going to drop down the 1. Okay. And then I'm going to multiply that by negative 3. Right. So negative 3 times 1. That's going to give us negative 3. All right, so again, we just multiply and we just write that here. And that's going to give us 7 when we add those together. Right? And then finally, the last thing we're going to do is we're going to multiply again. So we're going to take negative 3 times 7. That's negative 21. And that's a 0. All right, so here's how we write the solution to this. Okay, so every time we're done with synthetic division, the rightmost number is the remainder. Then the next digit is going to be the constant, and then the next is going to be the coefficient of x, okay? And so essentially, the way we would write this is 1x plus 7 plus 0 over x plus 3, all right? But we don't necessarily care about 0 over x plus 3, so that would just go away. And so our solution for this would be x plus 7, right? Which we already knew, right? So that's how we do synthetic division. It's actually really easy to do. Okay? A few more examples of this. So we have x cubed minus 7x minus 6 divided by x minus 2. And so we're going to write our division bar. We're going to take the opposite of what's inside of the x minus 2. Okay, in this case, it's going to be positive 2. Notice the coefficient of x cubed is a 1. In here, we're missing the x squared. So we're going to write a 0 for the x squared term. And then we're going to copy over a negative 7 and a negative 6. Now we're just going to repeat the process that we just did. I'm going to drop down the 1. And we're going to take 2 times 1 to give us 2. I'm going to add 0 plus 2. That's 2. And I'm going to multiply that by 2. That's 4. 7 times negative 4. Or 7, I'm sorry, negative 7 plus 4 is negative 3. And then finally, 2 times negative 3 is negative 6. And so we end up with a remainder this time of negative 12. Okay, that's okay. And so for our answer for this, remember, the way it works is that this is the remainder. This is the constant. This is the coefficient of x. This is the coefficient of x squared. And then you just keep going up in that order, okay? So our answer is just going to be x squared, or 1x squared, plus 2x minus 3, and then minus 12 over x minus 2. And that's our answer. A few more examples, okay? This is one that we already saw before, right? And so we're going to have to fill in some zeros here again. Now, another way to think about this is x to the fourth plus 0x cubed plus 0x squared plus 0x minus 21 or 2401. And we're going to divide that by x minus 7. And so when we set this up using synthetic division, the 7 is going to go on the outside, and then we have 1, 0, 0, 0, and then negative 2, 4, 0, 1. And we're going to use the exact same process that we just did. We drop down the 1, 7 times 1, 7. Add those together. 7 times 7, 49. Add those together. 7 times 49, 343. Add those together. And then finally, 7 times 343. Remember, we did that in the second video. That's 2401. We add those together, and that's 0. Again, the order in which we write the solution to this, we have 0 is the remainder, 343 is the constant, 49 is the coefficient of x, 7 is the coefficient of x squared, 1 is the coefficient of x cubed. And so when we write our answer to this, there is no remainder. And so that's going to be x cubed, or 1x cubed, plus 7x squared, plus 49x, plus 343. All right, and remember, since the remainder is 0, we don't need to consider that. All right, so that's all there is for synthetic division. Okay, synthetic division is actually a really easy operation to do. And again, it works really nicely when we have just this x plus c, or x minus c. Right? So in our final video of this series, what we're going to do is we're going to take a look at the factor theorem and the remainder theorem. Okay, two fairly easy to implement sort of properties, but going to be very useful to us a little bit later in the course.